memory management. For example, if you see here, if you go to my task manager, if you see here, there is a recorder option. Do you see this recorder option? Go to meeting recorder, right? The memory is increasing. If you see 824, 872, 896, why? I'm recording. Every second is being recorded into the video. The video size is increasing. Where is this video getting recorded right now? In the memory RAM. It's in the RAM. It's not saved back into the hard disk. This memory is allocated in the RAM. Am I right? So my program is recording this one, so it is taking and putting the memory. A program, as it runs, it takes memory. As it runs, for example, you will print your name in system.out.println, you are printing the name. It has to accommodate the memory for your name. You are printing 10 names in the memory, right? So the memory will increase. But for example, now I will stop the recording. Now I stop the recording. Should it increase? No. I stopped the recording. It should not increase. If it is increasing, what does it mean? There is a memory leak. A program takes memory. A program, see, for example, you are doing calculation, you are doing this one. So we take memory. A program runs in memory, RAM. A program runs in memory, RAM. Okay, random access memory. So as the program is doing so much of stuff, we are allocating memory. No one is creating memory. What is the capacity of my RAM? 4 GB. So max is 4 GB. So my operating system will allocate memory for me. Right? As I am asking it, it will give me memory. For example, think like I am working on a program. What I will do? I will go through all the student list in Whitebox QA and I will say that okay, I have to send an email telling that this is the assignment you have to submit by tomorrow. I will loop through all the list of these email addresses and then I will go and take the assignment and I will email each one of them. But once the email is sent, should I not clear the memory which is used? Right? If I did some purpose, I allocated memory, after I am done with the work, I should clean it, right? Right? That's what we do in real life, right? We have to clean our home every day. Means you have to clean up, right? Who does that? Programmer should do it. A programmer who is asking for memory, once the job is done, he has to clean it up. He takes memory for a program, so he has to clean it up. What is memory? Anything. For example, if I print something, if I take something, if I create, if I say in program int I is memory. Right? For example, if I say employee E is equal to new employee, that is memory in programming. Everything is memory. Got it? So if I create memory, it is my duty after I am done with it, I have to clean up that memory. That was done in C and C++. Memory management is done by programmer. Okay? For example, it will be very good, like for example, in our home, like you can wake up, you can do anything, but someone will come and clean it up. It's very good, right? You like that option? Right? Everyone will like that option. That is the option Java gives you. Automatic memory management. Automatic memory management. Okay? Management. For example, you do whatever you want, but the cleaning will be done by Java. But when to clean it? For example, think like I am watching TV and someone came and cleaning the TV. They are removing the TV. Will I like it? I'm using it. So when I'm using that memory, no one should remove it. Only when I'm done with it, they should clean it. So Java knows that okay, you're done with this memory, I should clean it up. That is called garbage collection. And there is a program called garbage. What is a garbage? Memory which is allocated and not used is garbage. Right? Memory which is allocated but unused. Allocated and unused is garbage. So there is a program which created there in JRE. There is something called garbage collector that will come and clean up. When will that run? It will run every time you come lower memory. It will automatically run when there is not enough memory. Okay, garbage collector is a program in JRE which will run automatically when there is insufficient memory. So that is garbage collection. You'll see it. It's a programming, so don't think it will be simple as I said. Okay. So garbage collection. First thing, JVM. So JRE contains three things. JRE contains three things. JRE contains three things. Let's see. First, one more thing. Actually, I want to explain one more thing. I wrote a Java program, right? I wrote a Java program. I compile it. What will I get? Bytecode. Who gave me the compiler? Which company gave me the compiler? Sun Microsystems or Oracle? We'll say Oracle from now. Okay. Now I compiled and I got bytecode from using a compiler from Sun. Got it? Now I am running this bytecode on what? I'm running this bytecode on what? Who is reading this bytecode? I wrote the Java program, I compile it, I give it to you to run. Who is really reading this bytecode? Does a programmer read it? JRE. JRE is the one. JRE on every machine will read it. Who created JRE? Who created Sun Microsystems? So the input and the output both are created by Sun Microsystems. Okay. So the compiler which gives bytecode, the JRE which reads the bytecode are both created by the same company. Got it? See and the JRE which reads bytecode are both created by Sun only. Why do no one else will create it? Actually, Sun sold licenses to other companies too. Microsoft, HP, IBM, they have their own versions of JVMs too. They can have their own versions. Okay. So we have not to. Sun is open source, right? That is the reason. Java is open source. That is the reason. But if you see history, for example, I am selling a bytecode. I wrote a complex formula that no one knows it, and I wrote it, and NASA wants to buy it from me. Okay, think like that. Okay, you don't have to laugh. Okay, think like that. Okay. So now, for example, I am putting it in a CD and giving it to some NASA. Someone came and changed the bytecode. Is there any guarantee that JRE will run it? There is a guarantee Java gives that it is written by me only. How will it give it? That is called code security. However, if I compile it and give it to you, you have to make sure that it is the same compile. No one changed in between. How will you make sure no one changed in between? Can anyone tell me what is metadata? What is metadata? What is metadata? What is metadata? Anyone? Data about data. Perfect. Metadata means data about data. For example, think like I am writing a letter to someone. But there are some gaps in the paragraphs. So I gave it to some other person. This other person can fill in the gaps and write whatever he wants, and he can change the context of the message. How will I guarantee that the other person got the message I intended? I will call that person. I wrote this in the message. Did you get it? I wrote this in the message. Did you get it? I called that person. I said that I wrote this in the message. Did you get it? Yeah, I got that message, and that is there in the message. That's all there in the message. There is nothing else. So this phone call is data about data. I am verifying the data with again repeating the data. Right? The letter is the data. Okay, why is there no order? Right, again, I think like I sent someone a letter.
Welcome to GoToWebinar, web events made easy.
This is what I wrote in the letter. This phone conversation is data about data. I am giving data about the data I have sent. So, for example, let's see how Java does it. It's very tricky and it is very funny. Okay. in a Java program, when you compile, what will happen? What will you get? Bytecode. But what is there in the bytecode? Bytecode is another language. It's not zeros and ones. Bytecode is different because machine is zeros and ones. Machine is zeros and ones. But nothing bad. For example, let's say, for example, I know one Indian language, you know one Indian language. We are communicating in what? English. English is the bytecode. You understood? Because we are communicating using, but English is converted to machine code to you, like in your brain, right? So, what I'm trying to tell here is an intermediate language. It's an intermediate language, right? It's an intermediate language. But who is giving that intermediate language? Compiler. So it's nothing. Bytecode is nothing but a conversion of a Java program into another language. Who understands this bytecode? For JRE. Why? Because JRE might run on Unix, JRE might run on. Why did we create this bytecode? Because we have different JREs. Every JRE can understand this. JRE on Unix can understand it, JRE on different operating system. That is why we created this intermediate language. Now see this. If I wrote a hello in Java, when I convert, what will I get in bytecode? Hello only in bytecode. But bytecode file will be larger than this one. Compiler not only just purely translates it into bytecode, it will create a metadata also. Now let's see what it is. For example, in this Java I wrote system.out.println. What did I write? Public class hello world, public static void main, and inside that what did I write? System.out.println, right? And I compile it. Then compiler will do what? It will convert this exact program into bytecode. Before that it will write metadata. This file has one class hello world. This file has one method main method. This file has one statement system.out.println. Done. That is metadata data. Now I will take this and give it to JRE. JRE will first do what? First it will read the bytecode. It will not run it. It will check the metadata. Metadata says that there is one class hello world. Does the bytecode have one hello world? Yes, bytecode is hello world. And it says there is one method called main method. Is there a one method? So it will use the metadata to validate the data bytecode. So can you beat the security here? Can anyone change? Everyone can change bytecode. Do you know how to write the metadata? Will Sun Microsystem share with you? It will not share. Security. Code security. Remember public key, private key. Here the private key is metadata, public key is JRE. Got it? Public key, private key. So that is how security is inbuilt into Java architecture. So if anyone changed my bytecode, automatically JRE will say that I won't run it because there is no metadata for it. How will be metadata produced? Only when you compile. But the compiler will compile a Java program. Will the compiler compile the bytecode? No. But simple. So code security. Did everyone get it? Understood? So in a single component there is two things, data and metadata. Alright? Agreed? So that is one thing. So these are the three things Java gives you. One is interpreter to convert bytecode into machine code. One is garbage collector to collect the garbage. One is code security. These are all done automatically. So if you see here, first you compile a Java program into .class. Then remember, actually there is one more concept actually, how to tell this. I want to read this PowerPoint presentation, right? I want to read this PowerPoint presentation. What will I do? I will open it. I will double click it and I will open it. What is this called? Loading. Loading a program. Now I compiled a Java program and I made bytecode. I give it to JRE. JRE needs to open it to read it, right? That is called class loading. To open a file and read the contents of the bytecode is called class loader. So loading a class and reading it. So first that takes time. If there are 100 bytecodes, 100 files needs to be opened by JRE. So that takes time. That needs to be considered. So here a programming running starts from opening a bytecode, then verifying the bytecode with what? Metadata inside it. With metadata inside it. Then once it is verified, what happens? You will convert this into what? Machine code. You will interpret this into machine code and you will run it. This is what happens. Okay. C program, when I compile, what will I get? A C program, when I compile, what will I get? Directly machine code. C program, C language program, C++ program. When I compile a C++ or C program, what will I get? Directly machine code. Is there this drama of like a byte code verifying and interpretation and then doing all this? No. Directly run it, right? But now we have to load the class and then verify it and then, interpret it and then do this one. So which one will be faster? Will a C program be faster? A Java program will be faster? C program. So C program is faster than Java program. Then you might say that if C program is faster, then why am I using Java? But you still can't accept slowness. You still can't take slowness for being secure, right? Then why are people still using Java? It is still faster. But how? That is called, there is a concept called JIT, just-in-time compilation. Any computer science graduate will know this. JIT, just-in-time compilation. So this concept again, to make Java code, to make Java execution faster, there is a concept called JIT. Just in time compilation. What is this jitting or jitter? What is this one? For example, see here, think like I have one Java file, I have one C program. One Java file is converted into class file. This is loaded. To load one file, how much time it will take? Fraction of seconds, milliseconds. Then verifying, it is single file, it won't matter. Interpretation, very fast and thing. But if it is 100 files, 100 files are loaded, 100 files are verified, 100 files are interpreted, then this one. So for small programs, it does not matter. For small programs, it does not matter. For huge, like hundreds and hundreds of classes, hundreds and hundreds of files, the performance shows up. That is why Java created something called just-in-time compilation. If there are 100 programs, you will have 100 classes. 100 classes are loaded into memory. They are verified. But Java will not convert every 100 file into machine code. Java will not convert the 100 files into machine code directly like that. Why it will not convert? Because a program starts at single line, then it goes to another line, then it goes to another file, then it goes to another file. So when you want it, ask me, I will compile and give it. But I won't compile everything 100 at once. So ask me when you need it. The program says that, oh, now I need another file. Then Jerry goes and gets that file and compiles it and gives it to that. Compiles means interpretation, byte code to machine code. That is already done. Memory, everything is loaded. Everything is loaded. 100 files are loaded, but 100 files are not converted into machine code. These 100 files are still in byte code only. They are converted as a needed basis. They are converted to machine code as a needed basis. So if there are 1000 files are not converted into machine code. They are still waiting. If you use it in the program, that will be converted. If you don't use it in the program, that will not be converted. So this is called just-in-time compilation. JITting. So now tell me which C program will be faster or Java program will be faster? You can't tell because architectures are different. It depends on number of files, how you execute, but still you can say Java is as up to the speed of C now. At least it is not very bad. Okay. So Java is comparably good according to C. So that is the concept. So now you will do one thing. Conversion interpretation. Yes, perfect. So what is code security in Java? What is garbage collection in Java? Write me a paragraph on every one of this and write it in your own words. Maybe I should also do something like this. What is that? In universities they use a software to find the plagiarism, right? I should also do that software to find the plagiarism on Whitebox K. Automatically when you submit it, it will go through the plagiarism thing and it will tell you where you copied and what you copied from. Okay, don't force me to do that. All right, yeah. The three things are JVM. The three things are JVM, code security, garbage collection. Three things in JRE are this one: code security and garbage collection. So now JVM is a pure interpreter only. JVM is pure interpreter. JRE is a bigger set. Alright. So that is the end of the. So JRE does three things. See here. Load it, verify it, execute the code. It loads the code, verifies the code, and executes the code. These are the three things of JRE. Okay. So where did we write our hello world program before? On the notepad. But notepad is not very easy, right? I need some software. If there is some syntax error, it should tell me where it happened. So what should I do now? I should go for an IDE. I should start working on Eclipse. So Eclipse, that is the reason. Why now you understand? Is programming in notepads very easier? Is it productive enough? No. We have to move to Eclipse. So that is the reason now we will do the hello world example in Eclipse. So when you download Eclipse, Eclipse is not installed. It is copied program. This is called Xcopy. Xcopy. Before, I do not know, I will tell a small story. Windows in 98 and XP, before XP, everything was installed. You have to install it. You have to put the registry, update the registries and everything. Then there is something happened called DLL hell. DLL hell. There is something called DLL hell. Read about it. Then it said that you don't have to install, just copy and double click it, it will run it. That is called Xcopy installation. What is Xcopy installation? Again, very good. What is Xcopy installation? And what is DLL hell? So from then, it is getting tougher to write programs for Windows at that time. For example, how many Office programs are there? Excel is a program, Word is a program, but all will use print function same, right? Print function can be same for all of them. So will they write the print function in excel.exe and word.exe? No, they will write in a separate DLL. DLL is a shared component. DLL is a shared component. But for example, if Excel got version 12, but Word did not get the version 12, Excel will update the DLL, but Word will not get the new DLL. Got it? It will fail. Compatibility issues. That is called DLL hell. If you install one program, it will break another program. It used to happen in 98, Windows 98 a lot. Okay, so that is what happened. So Xcopy means you just copy and double click it every time. So I have my Eclipse somewhere, I don't know where, but I have it somewhere. If you see, I have Eclipse here, not here. So I have Eclipse here. So you will have this and you see this one. Every time you have to go here and double click it. Instead of doing this, what will I do? I will say pin to start menu. Means I want it here somewhere so that I will use it every time. So what will I do? I will right click this one and pin to start menu. What will I do? I will go and open here. Right? So when you do it for the first time, so it is saying that who created Eclipse first? IBM. Okay. Then you will not see something like this. So is Eclipse used only for Java development? What else you can do with Eclipse? Is Eclipse only used for Java development? You can do PHP, you can do XML, you can do any other programming too. Eclipse is not an IDE for Java only. You can do many things. That is the great thing about Eclipse. So what I will do now is, for example, that is the reason it has perspectives. Means, for example, Java development means different files. PHP development means different files. So you have to tell Eclipse that from now I will do Java development. So you have to go to open perspective, go to window, open perspective and click other. And what is the development I am going to do here? What are we learning? C++, C? What are we learning today? So Java, click Java then. Okay, so it will adjust the windows for Java development. So what did it do? It is adjusting itself, making itself ready for you for Java development. You will automatically see this package explorer. Okay, it will automatically see this package explorer. For example, I will change the perspective now and let's say Java browsing. Then I will come back to again Java. Automatically it adjusted. You can close some windows here. There will be some windows here. You can close it. Now go to file. Everyone follow with me. So do you have this set up? Go to file, new, Java project. Do you see this Java project? I am creating a Java project. What will we name this project? WBQA. And if you see here, it is using Java SC 1.6. Means I am going to use which runtime? JRE 1.6. There are different versions for JRE. So I will be using JRE 1.6. Got it? Finish. I created a project. And open this project. Is there anything else there? Nothing. There is JRE attached to this. Do you see this JRE? Completely JRE attached to this. Alright, perfect. Do you see this source? Source is the program. There is source. On the source, you need to create a package, new package. Do you see this new package? On the source, right click. On the source, right click, new package. And now what will I do? edu.wbqa.basic. edu.wbqa.basic. Don't ask me why that is edu, why that is wbqa, why that is basic. Don't ask me, just write it. edu.wbqa.basic. Finish it. What happened? It created a name under it. So project should be there. Inside a project, package should be there. There should be a project, there should be a package. Inside the package, now right click on the package and new. What do you see there? Do you see a class? Click on class and what is the name of the class? Hello world. Hello world. H capital, W capital. And do you see this? What methods would you like me to create? Public static void main. Do you see this public static void main option? Please create it. I am lazy. I don't want to write it. So please create it. What happened? It created a hello world.java and it created this one and it wrote everything for you. Right? So what I need to write? Now I want to write a line here. Click enter and I need to write system.out.println. So print system and click dot. Automatically it is showing me list. Okay, there should be out. Do you see this out? And now I will click dot. Println. Do you see this println somewhere? Now I will put this and I will put semicolon and I will put this hello world or hello white box QA. How do I get the package? On the source, right click and new package and give a name. On the package, right click and new class. On the package, right click and new and class. And then run this. Just to use the top and always save resources before launching and it will automatically show this one. Okay, and run this. We have seen the architecture of Java, but we don't know how to program in Java yet. We just wrote a small program which we still don't understand. What is it? What is this public class? What is this public method and everything? Let's see the fundamentals of object oriented programming. Okay, there are two things. For example, I need to create for example a bank software, right? I need to create a bank software. Finally, what I need to give to the customer, I need to give a software where he can withdraw, where he can deposit, where he can transfer, where he can do with these accounts. That is the business I need to give. What to do? But is there only one way to write this programming? How to do? How to do is analysis. What to do is functionality, right? If you are testing what to do, that is called black box. If you are testing how to do, that is called white box. Alright. So how the developer wrote this program, if you are testing that, that is white box testing. You are using JUnit, Java and some other thing. If you are only, I don't care, whatever you write, I don't care. As long as on the user interface, I need to see that transferred money is this much or this one, that is black box testing. Analysis and design. Analysis tells what you need to do. Design will tell how to do it. The first concept of any programming or anything is called abstraction. There is a saying by Einstein, you cannot solve a problem at the level it is created. What does that mean? It sounds very good, right? That's it. You cannot solve a problem at the level it is created. At the same level it is created. Then what I need to do? Abstract. For example, my TV is not working. If you are working on the TV itself, you can't fix it. You need to go into circuits. You need to go into power cable. You need to go into some other thing. You need to go detailed inside it. Find the inner pieces, lay it out, and where it is not working and find that piece. So abstraction is nothing but digging deeper. Right? Abstraction is nothing but digging deeper. Root cause analysis, perfect root cause. But here, when you do abstraction, you will know how the system is made of. Right? You will understand how the system is made. If you remove this cable, volume is not coming or audio is not coming. If you remove this cable, video is not coming. So you will understand how the system is made. Abstraction means finding the starting from the lowest entity possible. See, when I need to make, for example, you bring me and say that, build me a bank system. I cannot think it. For example, if you bring me to a programmer or a designer and say that we will build a bank system for Bank of America, we got a project from Bank of America for bank system. What is the first thing I need to do? Abstract it. I need to dig deeper. Oh, bank means bank. There is a customer, there is a teller, there is a account. Accounts are 4 types: checking account, saving account, mortgage account, CD account. So I need to come from below. So thinking below is called abstraction. Start from bottom, right? So you need to laying out, that is called abstraction, right? So first I need to find out. So for example, in object oriented analysis, see, this is not programming. Object oriented analysis and design. I do not know if anyone went through a business analysis course. You should know this. Object oriented analysis. To solve problems, so object oriented analysis means to solve problems, there are many ways. Right? There are many ways to do abstraction. One of the way to do abstraction is called OOAD, Object Oriented Analysis and Design. You do not need to know Java for this. This is actually a business analysis concept. You can use UML diagrams to do this. Finding the entities inside a system and how they interact is called object oriented. Finding entities and how they interact is called OAD. Got it? Now, in OOAD, you have an entity. Now tell me, I want to create a white box QA system. Student portal. Student portal. Tell me the entities inside this. I want entities, not attributes. Entities inside the system. A student. Okay, next. Administrator. Administrator. Next. Course. Enroll is not a entity. Nouns. Think about nouns. Course. Presentation. Assignment. Diagram. Anything else? Say it again. Book. Book. Storing is not, see, verb. It's not a entity. Book is a entity. Recording. Recording. What result? Grade. Grade. What are you saying, Prashanti? Templates. Okay. Interview. Resume. Placement. All these are entities too, right? All these are entities too. Now coming with attributes. Now what does each entity have? What will student have? Tell me. Student. Student will have. Tell me. Username. Here we don't have IDs, but I have internal ID. But username. If he has username, what has he has password? Right? What else you used in registration system? Contact and so registration is an event which creates this entity inside the system. You see that? That is an event which creates the entity. Right? Logging in, let's log in a student login. So these are actors. Got it? These are actors. I am going too deep into UML, not now. What is administrator? Administrator will also have user ID, username and password. Username and password. Got it? Now, on student, what are the operations? Tell me the logic, operations. Don't go that far. Starting. Registration. Login. Assignment. Recording or something like that. Or getting placed. Right? This is an event for student. Right? Or making a resume. Resume made. Resume. Start resume. These are all operations. Logging. Yes, perfect. Now, let me tell me, what are the attributes of resume? Summary, name, projects, environment, right? These are resume. Agreed? What is the event on resume? Submit, right? Submit. Okay. All right. And if it is selected, what is the event? Interview is the event, right? So these are all. So it's an interaction of entities. So abstraction means finding out this and making a diagram, class diagrams and this one. So in databases, what will these entities happen? Called tables. They become tables. And attributes are columns. What are operations? What are operations? No operation in database. Now in Java, what is a entity? In Java, what is a entity? Class. What is a attribute? Variable. What is an operation? Functions or methods. So now you understood. So we have to build this system. That is nothing but software. Okay. In software, you have to make, in Java or any object-oriented programming, there is two things. You have to create the system. What does the system means? You have to create the system means define the system. Right? You have to define the system. You have to write the events which use this definition. See, I defined in the program student. I defined in the program interview, I defined in the program resume or something. But registration is the page which will lets you create a student, right? Registration is the page which, registration is an event. Registration is an event, but in the system that is student is a definition. Got it? I have to define, I have to write a program for, so let me tell you. What I told you, these are all the entities. Now I write Java classes for them. Java classes, right? Classes which define this one, define the system, right? I write a class for student, I write a class for interview, I write a class for some other thing, I write a class for book, I write a class for administrator, I write a class for recording, grade and everything. I wrote all the classes, I wrote all the methods. But then I have to give program, means now then if you go to whitebox QA, I wrote a HTML. For example, you will go to login, you will go to registration. I wrote a HTML which will call the student program. So I need to write a program which calls the definition program. There will be two programs, definition program, usage program. Got it? Definition is one. If I have that definition, I can have you register from, tomorrow I can create a whitebox QA, mobile app, iPhone app, Android app. The look is different. The definition is same. I can still use the same definition program, but the usage program will differ. So there will be two programs. Okay. So in Java, we need to write. So first, what is the first concept called? What is the first concept in object-oriented programming? Abstraction. So is there any programming in abstraction? There is. You need to write class. You need to write the class for student, you need to write class for administrator, you need to write this class. Writing definition, visioning definition itself is nothing but abstraction. So let's go and create a class today. Let's go and create a class. Let's say I want to create a new class. Go and create a new class in this one. New class in this one. In the same package, class. And let's say this is account. Let's say this is account. Okay. Account. And don't put public static void main in it. Don't put public static void main in it. Okay. Then you finish this public class account. Now inside this account, what you need to do is like, you need to tell me attributes of account, bank account. Tell me attributes about bank account. Tell me attributes for bank account. Withdraw is verb, not an attribute. Account number. Routing number is, let's not go that far because this is not that account number. Other than that, anyone else? Name of the holder, yes. Account number, address, I don't want to go that far. Give me account, simple account details. Withdraw is not a attribute. Attributes are columns, noun only. Deposit is also noun only. Checking or saving, account amount, yes, amount, the amount on that balance. So account number, account balance. Let's say account balance. So what will I do is now, right? Go here. Are you everyone inside the class? Is everyone inside the class? No? What happened? What happened? Is it with Eclipse or is it with your program?
It's just the layout change.
The layout change. Go to open window, open perspective and find other and click Java default. Okay. Now here, write public. Now I will ask you, what type is account number? See, when you create a column, you have to tell a type, right? Is it a number? Is it a varchar? Integer. This is integer. What type is account balance? Integer. Okay, double. Or what do you call decimal? Because see, my account balance I can have fractions too, right? Cents too, right? So you will call this as decimal, right? Now what will I do? I will say public int account number, and I will say public double account balance. Write like this. Create two variables. Okay. Here, what you can do with your account? What are the operations? You can check what is my balance. So write public int get balance, return account balance. Withdraw and deposit, but we will do it later. Yeah, make it double actually. That is a double, sorry. Public double. So write this class. This is a definition of an account, right? I created a definition of an account in Java. Now what will I do? I will create one more class and say this class as test1 and use public static void main inside it. Test1 use public static void main inside it. Got it? Now inside this one, public static void main inside this. Okay, is it fine? So is everyone lost? Okay. Now inside this one, okay, I will show this last class last line. Okay. Okay. How many classes I have? Account and test1. Okay. Inside this main method, what will I do now is, inside this main method, I will say, write like this, account A is equal to new account. And say A dot account number is equal to 1234. A dot account balance is equal to 500. Got it? If you have one definition, how many times you can create instances from it? As I told from last class, for example, I want to build a car. I will come up with the definition of the car, how it should be and everything, right? The design is that one. The design is the account class. Now I want to create accounts. So this is how an account is created. This is a real account. When you say new real account, you are using the definition to create an instance. Got it? You are using the definition to create an instance. Right? Say it again. A dot. Don't ask me what is dot. Don't ask me what is new. Next class. Okay. Then use sysout. Just write sysout and control space. Sysout and control space. What happened? Sysout and control space. Sysout. Just write sysout and control space. Sysout. Yeah, it created the print method. You don't need to write it. Right? Now, I will say a dot get balance. Print my balance. Inside that a dot get balance. Println means put anything inside this one, it will print it to you. That's what print. And it will create a new line after that. If you remove this ln, it will print in the same line as before. Okay. If you have two println statements, you will know the difference. Okay. If you have two println lines, then you will know the difference. Alright. Get balance. Alright. And I will run this. What did it print? 500.0, the decimal, because it is a decimal, it printed 500.0. So what did I do here? Okay, I will paste this one actually. Okay. I wrote the definition of account somewhere. I created an account from the definition. And I said my current account is A. And A's account number is 1234. A's account balance is how much? 500. So I wrote a definition. I created something from that definition. For example, in your brain you have many thoughts, right? But you can create from the thought something. So what you created is an object. What is inside your brain is a definition, right?
It returns 500 0. So we haven't given that.
Double, right? Double. Automatically it thinks it is a double, right? It's a double, so yeah, you have declared it as a double. So what is this? How it did it? Say it again. In the account.java. There is no class file here. Everything is compiling, everything is running, all is happening behind. So I don't want to show it. So I want to tell one thing.